Radioactivity, how to calculate half-life. How's it going, students? Today we're going to learn more about radioactivity and how to calculate half-life. Today you will learn what are isotopes. You're going to learn how to calculate the amount of an original substance remaining after a whole number of half-lives, and you're going to learn that radioactive elements become different elements. What are isotopes? Let's take a look at cobalt. When we look at the periodic table, the bottom number is the relative atomic mass. Remember that this number is protons plus the neutrons. This is a version of cobalt, and this is known as an isotope of cobalt. It is cobalt 59. 59 represents the atomic mass. As mentioned, this is an isotope, cobalt 59, and it can also look like this, CO 59. This is an isotope of cobalt. Notice the atomic mass. So therefore, it has an additional neutron because the number of protons remains the same at 27. This cobalt is shown as such, cobalt 60 or CO 60. Now, this particular isotope of cobalt is actually radioactive, and it is used in cancer treatments, food irradiation, and industrial applications. In fact, 70% of cancer sufferers who acquire radiotherapy receive radiation from cobalt 60. Let's calculate half-lives. So what is a half-life? Half-life refers to the amount of time it takes for half of a given substance to decay. Decay refers to an atom emitting particles and becoming a new element. An example is carbon-14 decays and actually becomes nitrogen-14. Half-life examples: uranium-238 has a half-life of 4.5 billion years. Polonium-210 has a half-life of 138 days. Let's take a look at some examples. The half-life of cobalt 60 is 5.3 years. If the initial mass of the sample is 2,000 grams, how much will remain after 26.5 years? Let's go ahead and write down our variables. So for cobalt 60, half-life is 5.3 years. Go ahead and write this next thing down. The initial mass of the sample is 2,000 grams. And the time elapsed is 26.5 years. You will be given 2 minutes to solve this problem. Let's see if you can do it on your own. All right, let's do it together. Let's review. How much are you starting with? Let's think about that. We are starting with 2,000 grams. So how much is left after 5.3 years? So we originally had 2,000 grams. And if one cycle of the element's half-life passes 5.3 years, how much would be left? Let's take a look at this image. What do you think it would be? The answer is 1,000 grams because it takes 5.3 years for half of the sample to decay. Let's take a look at another example. How much is left after 10.6 years? This is another half-life cycle. So we have 1,000 grams left after 5.3 years. What happens after another 5.3 years? It's going to be 500 grams. You guys get the idea? Every half-life cycle, 5.3 years, half of the remaining sample will have decayed. Let's continue. How much is left after 15.9 years? It will be 250 grams. Let's continue. How much is left after 21.2 years? So we have 250 grams. And then half of that will be 125 grams. Let's continue. How much is left after 26.5 years? At 21.2 years, we have 125 grams. Half of that would be 62.5 grams. Our final topic is new elements. So originally it was 2,000 grams of cobalt, but after one half-life cycle, 5.3 years, only 50% of that 2,000 gram sample is cobalt. The other 1,000 grams is actually the element nickel. Today you learned what are isotopes. Today you learned what are isotopes. You learned how to calculate half-lives, and you now know that radioactive elements become different elements.